Eto na ang programang magiging gabay mo upang ikaw ay matuto. DepEd 12 Radyo Eskwela! Makinig at matuto. DepEd 12 Radyo Eskwela! Alternatibong programang handog ng DepEd Soxargen na kahit saan ka man ay matututo ka. DepEd 12 Radyo Eskwela!
Naguguluhan, nalilito. Paano ba kung matututo?
Oh, hi there! Magandang Jensen! It's me, your teacher, Mimik. So today, we're going to have lots of fun and learning. So are you ready? Everybody!
If you want to explore all about science, come and join. Let us all learn. 'Cause science is fun. Science is cool. Watch and learn. 'Cause science is fun.
It is interesting to look back at the lessons you have learned about matter when you were in grade 7 and 8. Do you still remember them? Yes, in grade 7, you were able to describe the properties of metals and non-metals and to recognize elements and compounds. While in grade 8, you observed different common changes such as evaporation, condensation, boiling, and melting that helped you learn about the particles that matter is made of. You have also learned that the elements are systematically arranged and grouped in the periodic table of elements. Your knowledge about matter is continuously growing. In fact, in the previous unit, you were introduced to how electrons in different atoms are distributed. You have learned a lot so far. Studying this module will certainly increase your understanding about matter. Now, after this lesson, you all will be able to demonstrate an understanding of how atoms combine with other atoms by transferring or by sharing electrons. Specifically, explain the formation of ionic and covalent bonds, recognize the different types of compounds, whether it's ionic or covalent, and furthermore, you will be able to learn how to do the mapping of the periodic table, learn to write the Lewis symbol of some metal and non-metal elements, illustrate how an ionic bond is formed, and explain how covalent bonding takes place. Now, before going to our first activity, let us have a pre-assessment. I will be showing you a set of questions and I will give you 5 minutes to answer. And when the time is up, I will then be showing you the answer as guide for you to assess how much you have learned from your past lessons. Your pre-assessment starts now. 1, let us all watch a short video about mapping the periodic table. Here it is.
The periodic nature of elements, the periodic table explained. Although the periodic table of elements looks complex, it is easier to follow once you learn how to use it. First, the letters are symbols. Each box represents an element. Each element is made up of the same kind of atom with a specific number of protons in its nucleus, the atomic number. For example, H represents hydrogen. All hydrogen atoms have one proton. The symbol He represents helium. All helium atoms have 2 protons. The elements are arranged by increasing atomic number. The atomic number displays how many protons are present in the nucleus of the atom. The table is also very colorful. Each box is color-coded to show whether the element is a metal or non-metal, indicating the specific type. If you take a closer look at one element in particular, you will find its atomic number, atomic mass, element name, and element symbol. Looking at the overall table again, you will notice that it is made up of columns and rows. The columns are known as groups, and the rows are known as periods. All elements in a group have similar characteristics. These characteristics will tell you how many valence electrons, the electrons in the outer shell of the atom, are present in that atom, giving you an idea about how they bond. Here are the element groups and the number of valence electrons present. Count from the left, but skip over the transition metals because these are a little more complex. The periods display the number of electron shells that are present in the atom. We will not get into much detail about this, but notice that as you move down through the periods, the number of electron shells will increase. Another trend you will notice is the size of the atom, or the atomic radius. As you move down through the periods, the atoms become larger, increasing the atomic radius. As you move from left to right across the groups, the atoms become smaller, decreasing the atomic radius. The opposite is true for an atom's ionization energy, or how readily an electron can be removed from an atom. As you move down through the periods, the ionization energy will decrease. As you move from left to right across the groups, the ionization energy will increase. Knowing the basic properties of the periodic table will be beneficial to you throughout your school career. The periodic table allows scientists to determine the atomic structure of elements and predict how they might behave. Once you have a firm understanding of the periodic table, you will be able to apply it to experiments in your own classroom.
Now you are ready for our first activity. I will give you 5 minutes to answer, and when the time is up, I will then be showing you the answers. Timer starts now.
person you breathe. Everything you know is in your mind.
Before proceeding to our next activity, let us all watch first a short video about drawing Lewis dot symbols.
Howdy, y'all. Mr. Causey coming to you from beautiful Atascocita, Texas, with another homework helper. And today we're going to talk about Lewis dot symbols. Get your periodic table, and let's start. Some assumptions I'm going to make. I'm going to assume that you know what valence electrons are. I'm going to assume that you know the octet rule, the periodic table, and electron configuration or orbital notation. If you don't know these, you know you can go to my YouTube channel and find videos on all of these topics. All right, let's get started. The problem. Draw the Lewis dot symbols for the following: lithium, nitrogen, aluminum, and chlorine. Now we want to remember Lewis dot symbols are symbolic representations of the valence electrons in an element. And valence electrons are the electrons in the outer shell, usually the s and the p orbitals. The dot format goes like this, and this isn't a hard, fast rule. Later we're going to kind of bend the rules, but this is a good way if you're just starting to learn about Lewis dot symbols and how they help you understand valence electrons. Because once you understand valence electrons, you're going to be able to understand bonding, and a lot of other things are going to make a lot more sense. So this is an important task. 1, 2, that's the s orbital, because remember now it's the s and the p's in the highest energy level. 3, 4, and 5. And why did I do that? That's the Hund's rule. Each of those orbitals must have one electron before pairing. 6 and 7. There's our 8th. And that fits right into the octet rule. We have 8 valence electrons, or the possibility of 8 valence electrons. All right, let's look at lithium. Lithium, there's the symbol. Write down the symbol first. Then go to your periodic table, and you'll note there's lithium, and lithium has 1 valence electron. So there it is. We're done. Now, by looking at that, I also know that according to the octet rule, lithium was going to give up that 1 electron. And because it's willing to give up that 1 electron, lithium is going to end up with a +1 charge. It's positive, as most metals are. Let's look at nitrogen. Write down the symbol, N. Find it on the periodic table. There it is. Count over. 1, 1, 2, 3, 4, 5. All right, there's 5 valence electrons. So let's place them. 1, 2, 3, 4, 5. Now that helps me understand why nitrogen has a -3 charge. According to the octet rule, nitrogen is going to want 3 more electrons. And because it wants to gain 3 more electrons, it's going to have a -3 charge. It's also going to have a possibility of 3 bonds. I learned that all from the Lewis dot symbol. Let's look at another one. Aluminum. Write down the symbol. Go to the periodic table. Find aluminum. There it is. It's number 13. And look. 1, 2, 3. That means it has 3 valence electrons. So let's put them down. 1, 2, 3. And this helps me to understand that aluminum is more than likely going to give up those 3. It's easier to give up 3 than to gain 5. So it's going to tend to have a 3 plus or a 3 positive charge. Also, aluminum tends to have 3 bonds. Makes a lot of sense when I look at the Lewis dot symbol. All right, let's look at chlorine. Here's writing the symbol down. Go into the periodic table and let's find chlorine. There it is. 1, 2, 3, 4, 5, 6, 7. It has 7 valence electrons. So let's place them. 1, 2, 3, 4, 5, Hund's rule, 6, 7. And by looking at this, I can tell that chlorine is going to gain 1 electron because it's easier to gain 1 than to lose 7. And by gaining 1, it's going to have a negative 1 charge. And that negative 1 charge tells me that it's more than likely going to make 1 bond. All right, let's recap. You write the element symbol. You determine the valence electrons. You then draw the dots around this symbol following the pattern that was described here in the video. Happy ions, everyone.
Now, let us proceed to our activity 2. I will be giving you 5 minutes to answer, and when the time is up, I will then be showing you the answers. Timer starts now. just learned the relationship among the numbers of valence electrons, electronegativity, and ionization energy. You also realized that it is easy to write the Lewis symbol of the representative element. The information that you found out from the previous activity will be helpful in understanding chemical bonding. Do you know why atoms form compounds? Have you heard about the octet rule? Atoms always strive to attain the most stable arrangement of electrons. Atoms are stable if their electrons have the same kind of arrangement as that of noble gases, where the s and the p orbitals are filled with electrons, except for helium, where only the s orbitals are filled up. All the noble gases except for helium have 8 valence electrons. Now, the octet rule tells you that elements gain or lose or share electrons to achieve the electronic configuration of the nearest noble gas. Metals have low electronegativity and ionization energy. Thus, they tend to transfer all loose electrons, while non-metals have high electronegativity and ionization energy. They have a greater tendency to attract electrons towards themselves. Thus, non-metals tend to gain electrons. You will gain information about chemical bonding that involves gaining and losing electrons as you do the next activity. But before proceeding to our next activity, let us all watch first a short video about ionic and covalent bonds.
Chemical bonds, ionic and covalent bonds. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. Firstly, let me quickly teach you about metals and non-metals. We know that in the periodic table, group 1 and group 2 elements are metals like sodium, potassium, magnesium, and calcium. While we also know that elements like carbon, nitrogen, oxygen, and group 7 elements like fluorine and chlorine are non-metals. Now, how ionic bond and covalent bond exist when these atoms combine together chemically? Well, metals plus non-metals combine together chemically and they form ionic bond. For example, sodium chloride or table salt. Here, sodium is a metal and chlorine is a non-metal. So there is ionic bond between them. Secondly, when non-metals plus non-metals combine together chemically, they form a covalent bond. For example, carbon dioxide. Here, carbon is a non-metal and oxygen is also a non-metal. Hence, there is covalent bond between them. Thus, remember that ionic bond forms between metals and non-metals, while covalent bond forms between non-metals. Now, what is ionic bond or how we define ionic bond? Well, chemical bond which is formed due to complete transfer of electrons from one atom to other atom is called ionic bond. Note it down that metals having low ionization energy always lose electron or electrons, while non-metals having high ionization energy gain electron or electrons. For example, consider the formation of sodium chloride. Here in this ionic compound, sodium is metal and chlorine is non-metal. The total number of electrons in the sodium atom is 11 and the total number of electrons in the chlorine atom is 17. Remember that in the Lewis structure, we represent the electrons of one atom by the dot and the electrons of other atom by the cross. In sodium atom, there is only one electron in the outermost shell. We call it valence electron. And the chlorine atom, there are 7 electrons in the outermost shell, which we call valence electrons. Now listen carefully. If sodium loses this valence electron, it will get stability because its octet rule will be fulfilled. Secondly, if chlorine gains 1 electron, it will also get stability because its octet rule will be fulfilled. Thus sodium loses this 1 electron or valence electron and chlorine gains this 1 electron. Sodium becomes positive ion or cation and chlorine becomes negative ion or anion. These both ions have now opposite charges, due to which electrostatic force produces between them. This electrostatic force generates ionic bond between them. Therefore, we say that ionic bond is formed when metals lose electrons and non-metals gain electrons. Now, what is covalent bond or how we define covalent bond? Well, when 2 or more atoms join together by mutual sharing of electrons is called covalent bond. For example, consider the formation of oxygen gas. Here, let me write one oxygen atom and another oxygen atom. We know that the total number of electrons in single oxygen atom is 8. In the valence shell of oxygen atom, there are 6 electrons or 6 valence electrons. It means that if this oxygen atom gains 2 electrons, it will get stability because its octet rule will be fulfilled. Similarly, if this oxygen atom gains 2 electrons, it will also get stability. Now to stabilize themselves, these 2 oxygen atoms come together and mutually share 2 electrons. It means that one pair of dotted electrons come from this oxygen atom and one pair of crossed electrons come from this oxygen atom. So we say that 2 pair of electrons are shared between these 2 oxygen atoms to form oxygen gas. Also, you must know that these 2 shared pair of electrons neither belong to this oxygen atom nor belong to this oxygen atom. Rather, they belong to these both atoms. Therefore, we say that when electrons are mutually shared by atoms, they form a covalent bond.
Let us proceed to our activity 3, which is bonding by transfer of electrons. Bonding by transfer of electrons is ionic bonding. It is good to emphasize that this kind of chemical bond only exists between metals and non-metals. The best way in choosing the combination that will form ionic bond is by computing the electronegativity difference between the 2 elements. A combination which has an electronegativity difference of above 1.9 will result to ionic bond. Here is an example of ionic bond. Now, as seen on the activity, there are 2 elements, one metallic element and one non-metallic element. In order to determine if it is an ionic bond, we must first identify the electronegativity value of each element and subtract the given electronegativity values And take note that if the difference is greater than 1.9, complete transfer of electrons is possible, or it is known as the ionic bond. Now here are the guide questions we need to answer. Guide question number 1. What kind of element forms cation after ionic bonding, and why? Well, the answer is metals form cations because they completely transfer or give away electrons. Guide question number 2. What kind of element forms an ion after ionic bond, and why? The answer is non-metals form an ion because they attract electrons toward themselves. Guide question number 3. Why do ions form after ionic bonding? The answer is ions form after ionic bonding because this type of bond involves complete transfer of electrons. Guide question number 4. Did the atoms attain stability after ionic bonding? Explain your answer. The answer is yes. After ionic bonding, the participating atoms attain the stable electron configuration of the nearest noble gas. Guide question number 5. How can you tell that the ionic bonding will take place between metals and non-metals? The answer is ionic bonding will take place between metals and non-metals with electronegativity difference of greater than 1.9. Last guide question. Will all combinations of metals and non-metals form ionic bond, and why? The answer is not all metal and non-metal combination will result in an ionic bond. Only those with electronegativity difference of more than 1.9 will result to an ionic bond. For our last activity, the bonding by sharing of electrons. A covalent bond involves the sharing of electrons that results in the formation of covalent compound. Covalent bonds may be polar or non-polar. There are two types of covalent bond: the polar covalent bond and the non-polar covalent bond. If the electronegativity difference is equal to 0.4 or less, it results to a non-polar covalent bond. While if the electronegativity difference is less than 1.9 and more than 0.4, it is called polar covalent bond, or polar covalent bond is formed. Now, answer this last activity. I will give you 5 minutes, then after, I will show you the answers. Timer starts now. Before ending our session for today, I would like you all to answer this summative test as an evaluation to what you have learned. Now you may answer. done. Until next time, I am your teacher, Teacher Mikmik, and always remember, slow progress is better than no progress. Keep focused and study hard. This is our key to a better tomorrow. Good day and God bless. Bye everyone!
Eto na ang programang magiging gabay mo upang ikaw ay matuto. DepEd 12 Radyo Eskwela! Makinig at matuto. DepEd 12 Radyo Eskwela! Alternatibong programang handog ng DepEd Soxargen na kahit saan ka man ay matututo ka. DepEd 12 Radyo Eskwela!
Naguguluhan